Out of the cosmic silence, a whisper arrived. It was not loud. It was not dramatic. It was a simple, quiet beep. A single note played in the vast, dark concert hall of space. But this whisper had an unnerving quality. It repeated. It came again, and again, and again, with a precision that felt almost artificial, almost deliberate. This was not the chaotic static of the universe we have grown accustomed to. This was a pattern, a perfect, unwavering rhythm pulsing from an unknown source deep in the cosmos. In the quiet hum of a NASA data center, a monitor flickered with this impossible beat. For a moment, the universe felt a little less empty and a lot more mysterious. The signal was a spike on a graph, a thin vertical line indicating a burst of radio energy. After a precise interval of silence, the spike appeared again, and again. Each one was a perfect echo of the last. It was as if someone, or something, had set a metronome in the void and left it ticking for us to find. The signal was first captured not by a single person, but by a sophisticated system designed to listen for the faintest murmurs of the cosmos. The discovery came from a team of radio astronomers working with a large observatory, perhaps an array like the Very Large Array in New Mexico, or a single giant ear like the Late Arecibo Observatory. These colossal structures are our gateways to the unseen universe. They do not see visible light. They hear radio waves that travel unimpeded across billions of light years, carrying stories of distant galaxies, dying stars, and the very birth of the cosmos itself. On an otherwise ordinary day, one of these sentinels picked up the beat. The team was not looking for a message. They were conducting a routine survey, mapping a patch of the sky and cataloging the natural radio sources within it. The signal appeared unexpectedly in their data stream on 2025, August 22nd. A specialized algorithm, designed to flag unusual patterns, alerted the scientists to the anomaly. At first, it was logged as a candidate for RFI. Radio frequency interference. This is the constant battle against electronic noise. Stray signals from cell phones, satellites, and even faulty microwave ovens have famously mimicked cosmic signals in the past. The location was pinpointed to a small, unremarkable patch toward the constellation Vulpecula. No bright stars, no prominent nebulae. Just another piece of the infinite puzzle. The signal's persistence elevated it from curiosity to priority. It did not fade away. It did not change its tune. As the Earth turned and the telescope tracked, the signal remained, a constant, rhythmic pulse from a fixed point beyond our solar system. This initial detection set off a cascade of activity. The team, led by a meticulous senior astronomer, initiated a verification protocol. First step: internal. Cross-check instrumentation, review maintenance logs, analyze other frequencies to ensure it was not an artifact. When checks came up clean, they reached out to the global community. Are you hearing this too? So what did this signal actually look like? In radio terms, it was a narrowband, coherent, pulsed emission. Narrowband, coherent, pulsed emission. Narrowband, confined to a very small slice of the radio spectrum, around 1,420 megahertz. Most natural sources broadcast across wide frequencies, stars, gas clouds. A narrow signal is like a pure tone, specific, not chaotic. The roar of a waterfall versus the single clear note of a flute. Most compelling, perfectly repeating. A short burst, a fraction of a second, followed by a precise period of silence. Then an identical burst repeats. The interval was constant down to the millisecond. It did not waver. It did not drift. Clock-like regularity, rare in nature. Even pulsars slow and change over time. This signal showed no decay. Coherent. Waves in phase, like soldiers marching. High coherence versus jumbled, incoherent noise. This orderliness hints a compact, organized source. Narrowband, pulsed, coherent, an astrophysical outlier, extremely faint, barely above background. Algorithms had to filter and confirm it. If from interstellar distances, the source must be astonishingly powerful. A faint but structured signal made scientists sit up. It was a beacon, not a bonfire. Beacon, bonfire. Before you can claim you have found something from outer space, you must first prove it is not from your own backyard. This is the golden rule of SETI and radio astronomy. The verification process began with a rigorous hunt for local interference. Scientists checked everything: a new military satellite, radar reflections off space debris, a faulty piece of electronics on site. The team ran diagnostic tests. They pointed away and listened. The signal vanished. They pointed back. The signal returned. On source, off source, suggested it was coming from that direction in the sky. A secondary antenna listened for local transmissions. No correlating signal was found. They checked satellite transits, GPS, aviation radar. None matched. Next, independent verification. Coordinates and findings were shared confidentially with other observatories. Within days, a facility in another hemisphere confirmed the exact same signal, same frequency, same perfect repetition rate. This ruled out local malfunction or localized interference. The ghost was not in their machine. Further analysis. Doppler effect from Earth's orbit caused a sinusoidal frequency shift over the year, exactly as observed. Strong evidence of a distant stationary source. The signal was not terrestrial. It came from interstellar space. With terrestrial interference largely ruled out, scientists turned to the cosmos. The universe is noisy, filled with exotic radio signals. First suspect, pulsars, rapidly rotating neutron stars, collapsed cores of supernovae whose magnetic fields beam radio waves like a lighthouse. But the perfect signal did not fit a typical pulsar. Pulsars are regular, not perfect. They spin down. Intervals increase slightly. This signal, over weeks and months, showed no such change. Pulsars are usually broadband. This one was stubbornly narrowband, uncharacteristic of known pulsar physics. Another idea, a unique fast radio burst. FRBs can repeat, but sporadically, with varying brightness and shapes. They do not follow a clock. This signal was the opposite, faint, but perfectly metronomic. It lacked the chaos of repeating FRBs. Exotic natural models were explored, compact binaries whose magnetic fields interact, potentially producing a stable period. Gravitational lensing could create echoes of a single signal, but modeling reproduced the extreme regularity and narrowband nature? Difficult. Natural explanations increasingly required contrived conditions. The central challenge for any natural explanation is the perfect timing. Nature loves change, decay, fluctuation. One hypothesis: quasi-periodic oscillations from a black hole's accretion disk. QPOs are known, but in X-rays, not coherent narrowband radio.
The stability of the signal is the real puzzle.
Magnetars can burst powerfully, but could one be in a quiet, highly regular state? Purely speculative, never observed. Each natural path demanded fine-tuning, either a new class of object or time to reconsider hypotheses. When known natural explanations fail, science considers the improbable. For a narrowband, perfectly repeating signal, that means the technological hypothesis. The idea. The signal is artificial, a product of intelligence. Extraordinary claims demand extraordinary proof. A civilization might use a powerful narrowband transmitter at a magic frequency like 1420 MHz, neutral hydrogen's line, to stand out. A perfectly repeating pulse says, not random, deliberate. Carl Sagan. Extraordinary claims require extraordinary evidence.
Dr. Evelyn Reed. We are treating this as an unexplained astrophysical phenomenon. The data is compelling, but no leaps.
To claim technology, we need more. Is there complex information encoded? So far, none. A simple cosmic dial tone. The search for complexity continues. Teams search for modulation, prime numbers, mathematical constants, any non-random structure. To date, no message deciphered. The signal remains a perfect but seemingly empty beat. The discovery did not trigger panic or alien proclamations. It triggered quiet, intense work. Peer review began immediately. The team documented findings, methods, source analysis, and submitted to a journal. Reviewers challenged, requested data, proposed alternatives. A global campaign followed, radio, optical, X-ray, to build a multi-wavelength picture. As of 2025, radio loud, optically quiet, perhaps distant or dust-shrouded. Open data accelerated discovery, thousands of minds, one mystery. So, where do we stand today? We have a signal from deep space that repeats with the precision of a clock. We have ruled out with high confidence sources from Earth or our solar system. We examined pulsars, magnetars, black holes. None satisfy without new, unproven physics. We are left with a profound, tantalizing puzzle. It could be a completely new type of natural phenomenon, revolutionizing astrophysics, or something else. While we remain agnostic, a technological beacon cannot be dismissed. It remains a valid, if remote, hypothesis. Next steps. Keep listening. Continuous monitoring is essential. Does it change? Stop? Evolve in complexity? We need more powerful tools. Next-generation radio telescopes may reveal finer details or similar signals elsewhere. The search is a marathon. Patience is a necessity. Ultimately, this is about exploration, our desire to look up and ask, what is out there? Whether a new kind of star, a quirk of physics, or a message in a bottle, the answer will enrich our understanding.